Okay, so let's take some time today to graph our quadratics. And so, like I had said before, when you graph a quadratic, what it looks like is either like a U or it's upside down. It looks like the arch. Okay, so that's what our quadratics are going to look like. Now, when we've been graphing or when we've been finding our solutions to a quadratic, what we've been doing is we've been finding the point at which the parabola intersects the x-axis. So what does that look like? Let's say that this is, I'm going to draw it just kind of off to the side. If I have um, the x and y axis right there, and then I draw a parabola and might graph my parabola and it looks something like this. Okay, what we've been finding when we've been finding solutions graphically, we've been finding these 2 points. Okay, so we've been finding those 2 points. Um, they're called, when we're graphing, they're called roots. Okay, what is a quadratic root? So the quadratic roots are the points at which the parabola crosses or intersects the x-axis. Okay, remember this line right here is called the x-axis. Okay, so when we've been solving our equations, our quadratic equations, and we were setting them equal to 0, okay, at the very beginning, I had mentioned that we let y equal 0. That's what we were doing. We were finding out on the graph, where does y equal 0? Okay, and then another way to say, where does y equal 0? Where does it cross the x-axis? So quadratic roots, they're very important. They have a number of different names that we could call them. I could call them a solution. Okay, so that's what we were doing before. I was calling them solutions. So roots are the same thing as solutions. I also could call them x-intercepts, which makes sense because that's where they cross the x-axis. So we call them x-intercepts. Another name for them, which is kind of a awkward name, I think, but we should know it. It's called a zeros. They're called zeros. Okay. So we've got solutions, x-intercepts, and zeros, or roots. So we've got 4 different names for these points that cross at the x-axis. So a lot of the times, whenever you're graphing, you're going to end up with 2 solutions. Okay. It'll cross at 2 points. Okay. Because a U or an arch kind of loops around and comes back where it began. But there is a possibility that there's just one solution, and that would look like this, where your U turns right when it meets the x-axis. Okay. But there is one other situation where there could be no solutions. And what would that look like? Well, maybe you're making a U and it turns before it even gets down here to the x-axis. It never hits it. So you see that there's 3 different scenarios of solutions that you could come across. All right, let's scroll on down. Before we look at graphing these, there's one other very important point that we need to talk about on a graph. Okay, since we were kind of skipping around, let's talk about another very important point. So off to the side here, there's a little bit of extra room. I'm gonna draw a um, couple more graphs that we can look at. Okay. So I'm just going to draw any 2 parabolas, just very random. There's another point that is of interest to us. Yes, we like to find out what the points that cross the x-axis are, okay? And we'll find that out in some in in the next lesson with some application problems. But the other point is the highest point or the lowest point on my graph, okay? This would be the maximum point on this graph, and this would be the minimum point on this graph, okay? So these maximum and minimum points, so your parabola either has a maximum point or a minimum point, and we have a special name for those points, okay? They're called the vertex. Okay, and so what's the vertex? The maximum or minimum point on the parabola. Okay, so not only does a vertex occur at the maximum or the minimum point, which is, you know, a characteristic of our parabola that will be beneficial for us to know, but it also appears at what we call the axis of symmetry. Okay, that's a pretty fancy word. What does that mean? It means that if you split the graph into two right down the middle at that vertex, okay, it's going to be identical. It's symmetric on the left-hand side and the right-hand side, okay? It's like if you folded it on that line, okay? If you had this piece of paper and you folded it on that blue line, the parabola would match up very nicely. It's like a reflection. We're not going to talk too much about the axis of symmetry, but whenever we start graphing, it might make a little bit more sense if you understand why we pick the points we pick because of that axis. Okay, so now let's talk about how to find the vertex, okay? How can you find the vertex algebraically, okay? Because this is going to help us graph our quadratic equations. So I'm going to clear this away and scroll down. Okay. So the vertex, okay, we've got the definition of it. How do you find it? Well, first what we're gonna do is we're gonna find the x value of the vertex, okay? So a vertex is a point, right? It's a point. So a point is named by an ordered pair, okay? If we remember, we have to have the x value and we have to have the y value. So we're gonna have to find both of these values. So the first thing we're gonna do is we're gonna find the x value. And when your quadratic is written in standard form, okay, it's going to be negative b all over 2a, all right? So negative b all over 2a. Once you find your x value, your y value, all you have to do is plug this number into your equation, okay? And so how do we write that in mathematics? So if I want you to plug that value into the equation, if we remember, y could also be called f of x, correct? F of x is just another name for y. But so since I want you to plug this into the equation for x, what we say is f of negative b over 2a. Okay, that's how I will communicate how to find the vertex. Okay, so those are my 2 points. So my point here, my vertex point, negative b over 2a, okay, and then f of negative b over 2a. Sorry, that's kind of small writing, okay? All right, so let's do a couple examples here. So when we graph, the first thing that I want you to do is find the vertex. I'm going to make this as big as I can. Okay, so that's what we're going to do. We're going to find the vertex. I'm also going to, I hate that they don't label these, so I'm going to give these a couple names. Negative 1, negative 2, we'll go 1, 2, 1, 2. -1, -2, okay? Just giving it some labeling those a little bit. Okay, so let's find the vertex first. So step 1, find vertex. Okay, so the vertex is x equals -b all over 2a. Well, if we remember, the standard form is going to be ax squared plus bx plus c. So what's my b? My b is a +4. Okay, so that's what I'm gonna plug in. It's gonna be, you got negative, right? Negative b, -4 all over 2 times, what is a? I don't see a number in front. That means it's a 1. Okay, so what is that going to be? -4 over 2. That's -2. Okay, so my x for my vertex is -2. And then the y will be whatever happens after I plug -2 in for x. So be careful when you plug negatives in. I told you, you got to be really careful with it. So I'm going to take this, I'm going to plug -2 in for x. Everywhere I see an x, I'm going to plug -2 in. So this is going to be -2 squared plus 4 times -2 minus 5. So I just took this right here, plug -2 in, and all I have to do is simplify. You can use your calculator on this. They shouldn't be too crazy, but just be careful with your negatives. -2 squared is +4. 4 times -2 is a -8 minus 5. Y equals, let's see, we've got -8 and -5 make -13 plus a +4 gives me a -9. So my x is a -2 and my y is -9. So when we graph a quadratic, okay, when you're first learning how to graph a quadratic, what you're going to use is an XY chart. Okay, you got to use an XY chart. And so an XY chart, all you have to do is, depending on the type of graph that you're trying to graph, you pick a number of points. So, if we were graphing a linear equation, all I'd say is, hey, all you need is 2 points. And you could pick any 2 points. When you're graphing a parabola, you need a couple more points than that because the parabola changes. It'll swoop down and then go back up. And so you're going to need a few more points. Here they give you 7 that you could do. I would say you could get away with doing 5 points if you'd want. But a good place to start is that axis of symmetry, that vertex. So I'm going to plot the vertex first, and I'm going to put it in my graph. I'm going to put it right in the middle. I'm going to put my vertex right here because remember what I said, it's going to be completely symmetric on the left and the right. So that's going to give me a little bit, it's going to be easier to find some of these points. So I'm going to put -2 right here and -9. Okay, and so we can go ahead and plot that if we want. So -2 on the x, count over to the left, 1, 2, that's -2, and then -9, 9 steps down, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then maybe I'll do that in a different color actually too. Oops. Okay, so that's my first point. Now, what we're going to do is we're going to find points. I'm going to pick points on both sides of the vertex. So I'll pick -3 here and I'll pick -1 here. Okay. And so we'll plug these points into my equation. Okay. You plug these points now into your quadratic to be able to find your y value. That's what you always do when you're trying to find the coordinates. You find the x, okay, or you make the x and then you plug it in to find the y. So let's go ahead and find -1. Okay, so y equals negative 1 squared plus 4 times negative 1 minus 5. So that's y equals a positive 1 minus 4 minus 5. Y equals a negative 8. Okay. So I'm going to plot that point right there. So, or that's going to be, my y is going to be negative 8. So let's plot that point, negative 1, negative 8. Negative 1, negative 8. Now, remember what I said about how the vertex lies on the axis of symmetry. Since negative 1 is just one step away from negative 2, and so is negative 3 is just one step away from negative 2. Okay, I made it so that they were equal distance away from negative 2. What I get to do is at negative 3, I'm going to have the same exact value. I know that this is going to be negative 8, okay? Because, like I said, the vertex happens at the axis of symmetry, so anything that happens on the left side is going to be the exact mirror image of the right side. So it saves me time. I don't need to keep going. Okay, so let's do a couple more. Let's do 0, and I'll do negative 4. Now 0 is really easy to plug in, right? So all you're going to have is 0 squared is 0, plus 4 times 0 is 0. So those all go away. So all you have is y equals negative 5. Okay. Now, like I said, I picked these points so they're just one additional step away. They're both equal distance from the vertex. So this will also be negative 5. Okay. So I'll have 0, x equals 0, y equals negative 5. That's going to be 1, 2, 3, 4, 5. Get purple back up. And this will also be negative 5. Okay, so I want to keep finding a couple more points because my parabola, the way it looks right now, okay, and I'm just going to connect these dots. It actually goes on forever, but I haven't reached the x-axis quite yet. Okay, I want to make sure that I reach that x-axis because, like I said, it's of a lot of interest to me. Okay, so let's go ahead and do another point. And so maybe this time I'll do 2 steps away. So 0 to 2, and then so negative 4 to negative 6. Okay, I want to make sure that they're the same steps away from there so that I end up with that I can use that cool axis of symmetry rule right there where everything's going to be identical. So now what we have to do is we have to plug in a negative 2, or I'm sorry, yeah, 2, a positive 2 to our equation. So that's what I'll do. I'll do y equals positive 2 squared plus 4 times 2 minus 5. So y equals 4 plus 8 minus 5. Y is going to be 12 minus 5 is 7. And you know what? I probably could have done 1. I'm assuming that's probably where we're crossing. So we get y equals 7, and same here, y equals 7. So that point is 2, positive 7. 1, 2, 3, 4, 5, 6, 7. Okay. See how it shoots up there pretty quickly. Okay. And then also here, it's going to be negative 6. 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5, 6. Okay. Negative 6 all the way up to the 7 again. Okay. And so we'll see now if I would ask you, can you solve this quadratic? Okay. Well, there's lots of ways to solve our quadratic now that we know of. We could factor this quadratic. Okay. We could use the quadratic formula, but now we could also use graphing. And so graphing involves finding those points. Okay. finding those points where it crosses the x-axis. So it's right there. So if I would tell you to solve, okay, to solve this, we would have 2 points, okay? We would have 0, -5, and 0, +1. Okay, so let me slide over here on the side. So they asked us to find the solutions. What were the solutions to number 1? My solution was x equals -5 and x equals 1. Now remember, I told you one notation of writing multiple answers is to stick them into little squiggly brackets, okay? Um, let's go ahead and look at number 2. So the first thing you want to do is you want to find the vertex. So that's what I'm going to do. I'm going to find my vertex. So my vertex is -b all over 2a. So what is my b? So I'm going to erase b right here. I'm going to save some room. My b is -2. So when you plug it in, you end up with 2 negatives, okay? And then what's my a? My a is 1. Okay, right? My a is a 1. So what does that give me? -2 is a +2 all over 2, which is equal to 1. So my x is 1. So when I'm plotting that, I'm going to put the 1 right in the middle on my table, and then I'll find the x values that are on either side of that 1. Now let's go ahead and plug it in to our equation and find out what that y value is, okay? So we've got y equals, one way, and maybe I'll show you this notation. If I'm going to plug a value in, what I say is I say f of, what am I going to plug in? 1. F of 1 equals 1 squared minus 2 times 1 plus 1. So f of 1 equals, well, 1 squared is 1 minus 2 plus 1. 1 plus 1 is 2 minus 2, so that's going to be 0. F of 1 is 0. Okay, so we could plot our first point. We have 1, 0. So I'm going to go over 1 space and then up or down 0 spaces. So it'll be right there. Which is just really cool, guys. The vertex here is going to also be one of my roots. Okay, but if the vertex is the root, how many roots do you think we're going to have? Okay, how many times do you think it's going to cross my axis, okay, or intercept my axis? So something to think about. So let's do a couple more points. Let's do 2 and let's do 0, okay? I'm going to plug the easier one and I'm going to plug the 0 in, okay? So let's plug in f of 0 equals 0 squared minus 2 times 0 plus 1. That's just going to be f of 0 is going to be 0 minus 0 plus 1 is just going to be a positive 1. So since this is 1, this will also be 1. So let's go ahead and plot those points. 2, 1, that's going to look like that. And then 0, 1, that's going to look like that. Let's do one more set of points. Okay, so let's do the 3 and let's do our -1. Now you can decide whichever one you think might be easier to plug in, -1 or 3. I might plug in f of -1. Okay, so -1 squared minus 2 times -1 plus 1. Be careful with these negatives. -1 squared is a positive 1. Negative times a negative is a positive. So +1 plus +2, that's 3 plus 1 is 4. Oops, so that's down here, and since we're symmetric, this will also be 4. So I'm gonna go ahead and plot this point. So I've got 1, 2, 3, 4. It will also be 4 right here. Now you can see I've already got a pretty good picture of my quadratic going. And since I've already seen where it's going to cross the x-axis or intercept the x-axis as well, I'm not going to bother about filling in any more points. Okay, I think I got the picture. So it looks something like that. So what is my solution? Okay, the solution is where it intercepts the x-axis. So in this one, we only have one solution, and it's at x equals 1. So when we look at what are my solutions, okay, my solutions here are x equals 1. Okay. All right, let's do the very last one on this page. Okay, so let's find our vertex. Our vertex is going to be at x equals negative b all over 2a. Let's see, our b is 2, so I'll fill the 2 in there. And then our a, I don't see a number in front of there, so it's going to be a negative 1. So one thing I want to note, guys, is so far our A's have been positive, right? We had a positive 1 and we had a positive 1. This time our A is negative, okay? Our A is negative. Let's see what that does to my graph. What is having a negative A do to my graph, okay? So let's graph it and then we'll come back to that, okay? So I have negative 2 all over negative 2, so that equals a positive 1. So my vertex is a positive 1, so I'm going to write that right there. And then my f of a positive 1 equals negative 1 squared plus 2 times 1 minus 3, okay? Now you see in this one, my negative sign is not being squared, so it'll stay. So I have negative 1 plus 2 minus 3. Okay, that's going to give me a negative 2. All right, so I'm going to plot that point, 1, negative 2. So I go over 1, down 2. All right, so that's going to be right here. All right, so let's plot a couple more points. I'm going to pick the 0 and 2. So I'm going to plug in f of 0 because that's always really easy to find. Negative 0 squared plus 2 times 0 minus 3. So f of 0 equals, all that first stuff is just 0, and you're just left with your minus 3 or negative 3. So since that's negative 3, that's also going to be negative 3. So we get f of 0 is negative 3. So I got 1, 2, 3. 1, 2, 3. Okay, let's do one more at least. So let's do negative 1 and a positive 3. So let's do the f of 3. I got enough negative signs I'm working with. So negative, oops. So I have negative 3 squared plus 2x minus 3. Now, like I said, guys, this negative is not being squared, okay? It's just your x that's being squared. In previous examples, our x was in fact negative, but now since our x is positive, we're not squaring a negative number. So make sure you kind of know the difference between that. So f of 3 equals, let's see, that's going to give me negative 9 plus 6 minus 3. So I've got, let's write that out. That's going to be negative 9 plus 6 minus 3. That's going to give me a negative 12 plus 6 is a negative 6. Okay, so I have a positive 3 all the way down to negative 6. 1, 2, 3, 4, 5, 6. Okay, So I think I have enough to draw my picture. Now, if you notice, it doesn't look like it's going to cross my x-axis, right? Because even if I kept going, this parabola is just going to keep going down. Okay. So here, this is one of those spots where you don't have a solution. Okay. You don't have any zeros. You don't have any roots. Okay. Um, so our answer will be no solutions. But let's take a look really quickly. Remember what I said about this A being negative? Okay. Look at what shape my parabola is in. Okay. It's upside down. It looks like the arch. Okay. In our previous examples, okay, on number one, it looked like a U, and on number two, it looked like a U. But now it looks like an arch. And so this A, the sign of the A, is going to indicate to you, does it go up like a U or down like an arch? So let's go ahead and write that. Find somewhere nice and neat to write that. So when we talked about our vertex, okay, let's go ahead and look at that. If the A is positive, it's going to open up, okay? It's going to look just like that. And so I also want to indicate to you that this point will be a minimum, okay? Because in our Alex assignment, they're going to ask you, does the quadratic have a maximum or a minimum? And so the easiest way to look at that is see, hey, is my A positive? If it's positive, then my parabola has a minimum point. If the A is negative, okay, it's going to look like this. Okay, and so my vertex will be a maximum point. Okay, so just kind of note that it's a very quick way to look at your equation without having to graph anything and quickly say, do I have a maximum or do I have a minimum?